Now welcome. In this video we're going to be going through some trigonometry, and it should be a review of what you did in year 9 and year 10, but let's just go through it. Alright, so if I have, this is only for right angle triangles, so if I've got an angle here theta, right, then the key thing is this side over here is called the opposite side. It's opposite the angle, okay. This side over here is my hypotenuse, that's always opposite the right angle, and the one that's next to is called adjacent. Right, so the way I remember this thing here is SOH, so sine theta is equal to opposite over the hypotenuse. We know that cosine of theta is equal to the adjacent over the hypotenuse. We know that tan theta is equal to opposite over the adjacent. Now, let's just try not to, remember everything, but that SOH just covers it for me. It's the only thing I ever have to remember. Now, when we're going through our problem-solving strategy, I think the first thing that we want to do is we want to identify sites. And then we do basically the ratio, trig ratio. We want to basically then do is substitute and solve. And solve. And then the third thing we want to do is check to make sure that it makes sense. Okay, so let's go through some examples. I think the best thing is to do is just do some. So for this particular angle, opposite side over here, and that there is the hypotenuse. So that tells me I'm using sine. So sine of theta. Now you might want to write this opposite over the hypotenuse, and then do the substitution. Sine of 40 degrees equals opposite x over 5, and then to do our algebra we simply want to get x by itself, so that means I have to times by 5 to get rid of that. So therefore, and you write like this, x is equal to 5 sine of 40 degrees. So come to your calculator, so 5 sine 40, delete that one. Okay, and then go enter, and that's going to give me 3.21. Just go to 2 decimal places. So that's equal to 3.21 meters. Right, so I've done my identify, substitute, I've solved it. I've now got my answer. Does that make sense? I think 40 degrees, the other angle up there has to be 50, so therefore we would be thinking that's got to be less than 5 meters. So okay with that, I'm happy with the fact that we've probably got the right answer. Right, so let's go to this next one. Alright, so we're looking at this example. So we're going to identify our side. So this again is my opposite side over here. This is next to, that's my adjacent side, so that's the TOA. So tan theta equals opposite over adjacent. So tan of 60 degrees is equal to opposite 7 over x. Alright, so this is the thing I've got to solve. Again, I've got to do my opposite operations. Alright, so I quite like this thinking, which is x is equal to 7 divided by tan of 60, and I'll explain that process. To get x by itself, I've got to times by x to get off the bottom line, so that's what I've done. And then to get that, I would have had, in this scenario over here, I would have had x tan 60 equals 7. Now, the opposite of that is to divide both sides by 60. So therefore that brings that down to the bottom line. Now once you get used to these, the algebra is always going to be that goes to the top, that goes to the bottom. And so you can do it in one step. And so therefore, let's go to a calculator. So 7 divided by tan of 60. and that's going to give me an answer of 4.04. Again, checking to make sure that that makes sense is a good thing. 4.04 meters. Because the angle there is going to be less than 60, so therefore that sounds reasonable to me. Right, let's do the next one. Alright, so over here, identify our sides. This side next to here is my adjacent side. This side over here is my hypotenuse. Okay, so that's my hypotenuse. So that means I'm going to be using cosine. Cosine of theta equals my adjacent over my hypotenuse. Alright, so now I substitute it in. So cosine of 70 equals my adjacent, which is x over my hypotenuse, which is 3.7. Okay, I've got my unknown on the bottom. My unknown's at the top side. I just need to get rid of that 3.7. So because it's divided, I have to times by it. 3.7 cosine of 70 equals x. Or we could just go over here and go x is equal to, doesn't really matter because it's equal. Right, so now I go to my calculator. So 3.7 cosine 70. It's going to give me an answer 1.27, rounding that up. Equals 1.27 meters. Again, that angle, that side over here is going to be, on this angle here, be 20 degrees. So it's going to be a much smaller side. So that makes sense to me. Let's keep going. Alright, so this one over here, we've got adjacent side over here. And we've got our hypotenuse over here. So again, that's telling me I'm using cosine. So cosine of, you can do this, 42 degrees equals my adjacent, which is 4.8 over my hypotenuse is L. So once you get really good at this stuff, you can do that. It's up to you. I'm not going to say it's wrong if it saves your time and you're okay with that. Again, because my unknown's on the bottom, I have to times my thing over here. So remember I said you could skip this step, but let's do it. 42 equals 4.8, and therefore L, because I'm timesing, I have to divide, and that becomes equal to cosine of 42 degrees. Alright, I'm happy for you to go straight to that line in one go if you like. So now let's do this on the calculator. So it's 4.8 divided by cosine of 42 degrees. And that will give me 6.46. 6.46 meters. Again, looking at that, okay, this angle over here would have to be like 50 or 48. So therefore, bigger angle, bigger side. Because we're looking at this being 90 degrees, we're expecting the angle to be much bigger than the length to be much bigger than 4.8 meters. So that makes sense to me. All right, the last one, okay, we've got here to do today is again the same process. So no matter what you're doing, whether you're finding an unknown at the bottom, unknown at the top, it's really the same process. Whether you're using sine, cosine or tan, it doesn't really make any difference. Just going through a process. That angle there, this is the opposite side. That there is the hypotenuse. So therefore I'm looking at using sine. So sine theta equals opposite over hypotenuse. Sine of 55 degrees equals opposite, which is 8 over my W. That's what I'm solving for. Again, if you want to do the process in 2 steps, you can. I'm going to go unknown W is equal to 8 divided by sine of 55 degrees. And now I'm going to my calculator. 8 divided by sine of 55 and that's going to give me something like 9.77. So 9.77 metres. I'd expect that side, because it's the hypotenuse, to be bigger than the other side. Okay, so that all makes sense. If you keep in mind the key things that we've got up over here, the steps are identify the side and the trig ratio, substitute and solve there. Okay, there's really only two things you're solving for, one where it's at the top, one the unknown's at the bottom. Okay, and then you need to make sure you check your answer and make sure if it works properly. Alright, if you need some help, make sure you catch up with either the Math Online stuff or myself in class, and we can go through that.